Okay, there are a few things first I want to draw your attention to, okay? And then we'll do the disagreements. But I want you to look at the answers on the board for number one, for J, K, O, P, Q, R, and S. J, K, O, P, Q, R, and S. What do those all have in common?
Negative sign.
They're negative signs, right? So then let's look at the questions for those problems. Look at the questions on J and K, for example. What values do we have in there? Oh, decimals? Okay, then do it again.
Fraction.
Fractions? All right. So then let's look at the values for M also. What do we have in M? It's also decimals, but is the answer for M negative? No, so then what's the difference now? What's the difference? You said decimals, right? All of these negatives have decimals, but I'm pointing you, M has a decimal number in there, but M is not negative. Okay, I need somebody to help a little bit. She's on the track, she's got no zeros. But technically, what are we really looking at for those values that have negatives? What do they look like? Fractions, there are, because 8 over 3 is a fraction, right? So what kind of fractions are we looking at in there? Come on, people. Hmm? It will be an improper fraction, but it's still a fraction. You know? A short human being is still a human being. Okay. What I wanted you to go to, and I think that's what you're going to when you say fractions, but you have to be careful because fractions don't necessarily mean it's less than 1, right? We have improper fractions, right? But the fractions we have here, or the decimals we have here, are all less than 1. They're all smaller than 1. You see that? So if you compare those answers that have all negative values here, and you go back and look at what they're asking us to find, all of those values are smaller than 1. And so if I have an argument smaller than 1, and I'm trying to find a log base 10 of that thing, my answer has to be a negative. If I know the positive value, I can find the smaller value for that. So for example, what's 2 to the third power?
8.
8? Okay. What's 2 to the negative third power?
1 over 8.
1 over 8. You see that? So then if you look in the box on the top of this page, the rectangle at the top of this page, look at the third bullet point in the rectangle at the top of that page. I wanted folks to see if they could come up with that. That's why I didn't stress it yesterday. But what does the third bullet point say?
For positive real numbers, x log 1 over x equals negative log.
For positive real numbers, if I want to find the log of 1 over x, I don't want to waste my time trying to do fractions and flipping. Yesterday when I did the fraction, all you were there, we still doing that? That's doing the most, right? Well, if you don't want to do the most, then just flip it and make sure that it's going to be negative. Right? I know what 32 as a power of 2 is. So if you ask me to find the 1 over 32 as a power of 2, I'm going to find what this is and make the exponent negative. It's exactly what, almost similar to what you're doing. Okay? So let's look at the disagreements. Okay. Not a lot of disagreements here. I'm hoping you will pay attention. we agree this is not a disagreement, right? Oh, so you changed it. Okay. Okay. Let's look at starting with C. C says we should find the log base 10 of 33. We should find the value of it. This where I am, is this large enough? Alright, make sure you bring your glasses next time. Okay. So we need to find the exact value of this thing based on what we have out there. We're good? So how do I break this
11.
into factors? 11 and 3? Because 11 times 3 is 33? Okay. So this is the log of 11 times 3. If I have a multiplication, how do I break that up? If I have a multiplication here, how do I break them up into individual ones?
I said, Jim.
Split it to a what? Add them up. I know, I got you. The log of 11 plus the log of 3, right? Do we have a value for the log of 11?
Yes.
What is it?
1.04.
1.04 plus what? What's the log of 3?
0.48.
0.48. If I add these two things up, I should get 1.52.
Yeah.
So one of the biggest things, like I said yesterday, that we need to survive this section will be to know all of our factors, right? Know your prime factors. Questions? Found the mistakes for the disagreement? All right, let's go on to H. Problem H is asking us for the log base 10 of 99. Just find J later. So J. So again, we don't have 99 on the board, but we can break 99 into prime factors so that it has one of those prime factors in it, at least all of them. So how do we break 99?
11 through
11 times 9 first, right? Alright, but 9 is not a prime number, and it's not on in the table, so we have the log of 11, and then 3, and 3. That's what we've been doing, but you should have been here yesterday. You know we had school yesterday, right? I did not ask why. You want to move in out of last semester when you were always absent. You see that? So we could either keep doing it this way and say, well, I'm going to do the log of 11, which we had as 1.04, plus the log of 3, which is 0.48. So technically, the log of 33 plus the log of 3. Because we already had the log of 33, right? What's 33 times 3? 99. So we could just say, take this, do it plus the log of 3. Add 1 more 0.48 to it. That's the answer for the log of 99. But we had to do all this work just to add on to the climate change. Now we're going to have another snow day again because we're doing way too much work. Y'all seen that? There's so many ways, so many shortcuts. Y'all keep asking for shortcuts. Here it is. I could also say, how many of these things do I have here?
2.
2 of them. So I could also write this as the log of 11 plus twice the log of 3. Because this is 3 squared. All right, I got it 2 times. 9 is 3 squared, right? Because I see my cousin going, oh, yeah, there is a property I didn't point out yesterday. I wanted you to do this work and see if you could find a pattern and then make a conjecture, right? Again, stereotyping, right? That's all it is, right? We see a pattern, we make a conjecture, right? Let's stereotype based on this. There might be something that happens with that. We're seeing quite a few teenagers come through the store and shoplifting. So now we just assume every teenager that comes here is going to shoplift. I didn't say it was right. I'm just saying it's based on patterns. Remember the guy up there by the old high school who would keep you outside even when it's snowing and you come in one at a time? You got to take out your backpacks and everything because some of your cousins shoplifted for him. So now he assumes that everybody's going to do it. We're good? So here's the property I was trying to highlight. The log of whatever base, so call that base A, of x to the n, can be written as n times, because here's the thing, if I had a 3 squared, and I'm doing 3 plus 3, what happens if I had the log of, say, 3 to the 1,000? So that means 3 times 3 times 3 times 3 times 3 times 3, 1,000 times, right? And we agree if it's a multiplication where we add, so we're going to have the log of 3 plus the log of 3 plus the log of 3 plus the log of 3 all day. Right? Yeah, that's why it starts to snow in April in Minnesota when you keep doing all those work. But we know it's the log of 3 added to itself how many times? 1,000 times. So all I need to do is to know what's the value of the log of 3, and I'll just multiply that by 1,000. All right? So climate change. Don't add up to it. I'm from Liberia. We're surrounded by water. You adding up the climate change, my country might disappear soon. And I don't want that. Let's do J. J is asking for the log of 0.0014. Well, you're in math class, so I want you to put whatever you're studying right now away. Otherwise, when I take it, you don't get it back. So J. (0.0014). Now, that is a decimal number less than 1, right? So what should we expect our answer to be? A negative. Right? The other day I showed you how to write these things as scientific notation, right? So let's do that. Now, I know if it's scientific notation is going to be 1.4, but trying to find numbers that multiply to 1.4 is going to give me a lot of work. So I'm going to violate the rules of writing scientific notation just to get my life easy. And so we move this 1, 2, 3, 4 times. So I get 14 times 10, negative 4, because we're moving the decimal point back. And so it's a negative 4. It's the same problem we still have, right? It's always times 10. If it's decimal, if it's scientific notation. Another thing we could do is to say, well, we have this number, 1, 2, 3, 4 over 1, right? Because every number as a fraction is over 1. and then we just convert it to fraction if you like. I move this one time, add 1 0, add another 0, add another 0, add another 0. 1, 2, 3, 4, 0 because I move it 4 times. So this number is technically 14 over 1 with 4 zeros. See that? So I could choose to use this number instead of this number, but I get the same answer. Because again, when we are dividing, we subtract, right? So we have the log of 14 minus the log of 10,000. You can do that. If you're lost on scientific notation, you go back to learn how to convert fractions. So this is the log of 14 plus the log of 10 to the negative 4. How do I write the log of 14? What are the factors?
72.
72. So the log of 7 plus the log of 2 plus the log of 10 to the negative 4. If we don't have a base, what's the base? We know it's here. 10. Right? So what's the log base 10 of 10 to the negative 4?
Negative 4.
Negative 4, just the exponent. We know the value of log of 2. What is it?
0.30.
0.20?
30.
0.30. And the log of 7?
0.85.
0.85. So you add these two, take it away from 4. Or take 4 away from it. See that? So we will end up with a negative number because negative 4 is bigger than whatever 0.85 and 0.30 gives me. Which is 1.15. Right? Is it 1.15? Okay. See that? Anybody want to see how that turns out also with the fractions? Those who don't care about scientific notation? Because I see a few people doing Bible here, right? So this becomes the log of 14 over 10 to the 4 power, right? Right there. So this is the log of 14 minus the log of 10 to the 4th power. Because again, we're dividing, right? The log of 14 is just the log of 7 plus the log of 2 minus the log of 10 to the positive 4. Well, what's the value of log base 10 to the 4th?
4.
Again, I have a minus 4. See that? And I have these two values just from right here. Same thing. 7 plus 2 minus 4. 7 plus 2 minus 4. Questions? So if you know how to convert between decimals and fractions, you could do that. Whatever makes you happy. Or you write out scientific notation. And the problem is there's quite a few scientific notation in this section. So I would advise that you try to at least remember the time on how to deal with that. So let's look at problems 2. Problem number 2 is C has a disagreement. So let's look at C. What's the problem in C? Number 2. The log of 15 minus the log of 5. So 2C. Well, based on what we just did here, we had a subtraction because it was a division, right? So now we're trying to condense it, we make it a division, right? So this is just the log of 15 divided by 5.
Log 2.
Yes. Questions? The answer you gave me earlier.
That would make sense.
Hmm? Okay, and then the last one we have a disagreement on is D. What is the question on D? Log of 8 plus log of 1 over 4. Okay, so D, the log of 8 plus the log of 1. So we have a plus, and so what are we doing here?
Multiply.
We're multiplying. So this is going to be the log of 8 times 1 over 4.
You can multiply.
Yeah. If I'm multiplying by a fourth, it means I'm just dividing by 4. Right? Or you can multiply 8 times 1 is 8. 1 times 4 is 4. What's 8 divided by 4?
2.
This is the same as the log of 2. Anybody with a question? We're good? Okay, let's do today's work. For today's work, I want you to go back to page 68 plus 1. Page 68 plus 1. Everybody got 68 plus 1 or 70 minus 1? So, let's do this.
She got 2? Oh, period. Tell me what style with the new trend. I'm here for it.
Okay.
I can keep
Hey, let's do this. The instruction up here says use the C word. All right. You know we don't like that in this room. We're getting away from that. Unless you were born with that calculator, we're trying to get away from it. So we try to put batteries in these ones, the ones you were born with. Okay? We are given page 68 plus 1.
So that's what he meant with clever.
We got 1 through 9. And they're asking you to use the calculator to get this side. I would say the only reason we would need a calculator would be just to add up decimals. Right? So we already know. Can somebody tell me what's the log base 10 of 10? What is the 1? Why 1?
Because the thing on the 1, I mean the 10 is a 1.
10 to the 1 power, right? So the log of the base of the argument being the same is just the exponent. So log base 10 of 10 to the 1, just like we had log base 10 of 10 to the 4th was a 4. Okay? So we know this is 1. Now that we know that, can somebody tell me how to find the log of 12 by using the table based on what we already have?
1 plus 0.3010.
The log of 12?
No,
How do you find the log of 12?
you could break it.
You break it using what?
6 and 2, 4.
Seems like I have only one person in this room today. So slow down a little bit. I need other people because it's like I just here breathing my oxygen for free. So 12. Based on what we have in the table, how do we find the log of 12? 6 and 2? Because 6 times 2 is 12. So we add a value of 2 and 6. Are there any other numbers we could also use?
4 and 3.
4 and 3. And they will give us the same value. They would give us the same value. So use 4 and 3, the sum of 4 and 3, or the sum of 2 and 6, you get the same answer. Because they all multiply to 12. You see that? So for the next one, 16, what will we use?
8 and 2.
8 and 2 or
4 and 4.
4 and 4, right? 2 times 4, 2 times the value of 4, which still give me the same answer. Everybody seen that? Okay. So your work for right now, and until you come back from your long vacation you're about to go on, is to find at least 2 other folks, cousins that can stand you, that will want to work with you, and that you can stand and you want to work with, to finish everything on page 68 plus 1
Takashi.
and page 70. So you end it on page 70. Okay? 68 plus 1 to 70. That is your work for now, and it's also the homework. Do it right now so you don't have homework to do, and then you can practice for your retake on Monday. We're good? Because if you don't do it right now, you're going to forget. And then we're going to have a problem when you come back and then do my homework. We all right? Black Pie out.